So what I'm going to do is basically work through a test review, and then if you have any questions, feel free to stop me. If not, I'm just going to work through the test review. And this is I pretty much pulled this review from one of the reviews that you could be working on. So it's just like what you're working on, just with different numbers probably. So, number 1, solve the absolute value equation. Okay, so to solve the absolute value equation, when you're solving an absolute value equation, you want to get the absolute value by itself. So to start that, we're going to subtract this 10 on both sides. So then I'm going to have the absolute value of x plus 3 equals 4 minus 10 is negative 6. Now, the absolute value of something, it means the distance that number is from 0. So the absolute value must always be positive. So when you're solving an absolute value equation and at any point you get the absolute value equals a negative number, if this happens, that means that you have no solution. This can't happen when you are solving an absolute value equation. Now, you have to just kind of remember that, because you could go and continue steps as if you could solve it, and you will end up with some answers. But if you take it and plug it back into your equation, they're not going to end up both being correct. So again, when you're solving an absolute value equation and you end up with the absolute value equals some negative number, then that means that this equation has no solution. And in MAT1033C, it's going to have 2 spaces to put your solutions. So what you want to do in MAT1033C, you're going to type DNE into both spaces, which represents does not exist. Okay? All right. Number 2, another solve the absolute value equation. Now this one we can solve because the absolute value equals a positive number. Okay? So we can solve this. So we're going to start by writing our 2 equations. The first equation, we're going to just drop the absolute value signs, set it equal to the right side. Then the other equation, drop the absolute value, equals the opposite and negate the right side. So now we're going to solve them each individually. So to solve for x in the first equation, we're going to subtract 2 from both sides. I'm going to bring down that 4x, 2 minus 2 cancels out, equals 11 minus 2 is 9. And then now to solve this variable, to solve for x, we're going to divide by 4. 4 over 4 cancels, and then we have x equals 9 over 4. Okay? Now to the next one. So same thing, we're going to subtract 2 from both sides. So then we're going to bring down that 4x, 2 minus 2 cancels out, equals negative 11 minus 2 is negative 13. And then to solve for x, we're going to divide by 4. So x equals negative 13 divided by 4. And these are our 2 solutions. Okay, number 3. Solve the compound inequalities Okay, I have a question. Okay. So to solve the compound inequalities, we're going to solve them individually first. So we have x minus 72 is less than or equal to negative 80. So to solve for x, I'm going to add 72 to both sides. I'm going to bring down that x, negative 72 plus 72 cancels out. X is less than or equal to negative 80 plus 72 is negative 8. Okay. And let's solve the next one. So to solve for x in the second inequality, we're going to add 80 to both sides. So I'm going to bring down that x. Negative 80 plus 80 cancels out. X is greater than or equal to negative 71 plus 80 is positive 9. Okay, so now we have just solved these singular inequalities. Now we're going to put them together. This is an AND compound inequality. So that means that the solutions must overlap. So I like to put it on a number line to see what's going on better. So I'm going to color code this. So I'm going to make this yellow and this green. So negative 8, we'll put this on the left. 9 we'll put on the right. So x is less than or equal to negative 8. So this is negative 8. All the values less than negative 8 are to the left. And then it's equal to, so we're going to use a bracket. So this is what your graph would look like. Okay, for x is less than or equal to negative 8. Let's look at the next one. X is greater than or equal to 9. So here's 9. All the values greater than 9 are to the right. And then it's greater than or equal to, so we're going to use a bracket. This is going to be your graph for that inequality. Now, if we need the overlap, it is not overlapping. There is no overlap. So that means that it is no solution. Okay? And then, so that means for the answer, you're going to type does not exist. And there is no interval notation you would write because there is no interval that is your solution. Okay? All right. Number 4. Solve the compound inequalities and write the answer in interval notation. So we're going to solve them separately first. So to solve for x, the first thing I'm going to do in this first inequality is subtract 18. So I'm going to bring down that negative 8x. 18 minus 18 cancels out. Greater than 34 minus 18 is 16. And then we're going to divide by negative 8. Now, we're dividing by a negative. So that means we have to flip the inequality. That's going to turn into less than. So now we have x is less than 16 divided by negative 8 is negative 2. Okay? So now let's do the next one. So we have or. This was simpler, so subtract 1 on both sides. So we have x is less than 9. Okay. So for an or inequality, we want to include everything. Everything is included. So again, let's put it on a number line to see what it actually looks like. So we'll put negative 2 on the left and 9 on the right. Okay, so, oops. Okay, x is less than negative 2. So here's negative 2. All the values less than negative 2 are to the right. And then we are not including negative 2 because it's not equal to. So we're going to use parentheses. Now, the next one. X is less than 9. Everything less than 9 is to the left. And we are not including 9 because it's not equal to, so we're going to use parentheses. So because this is an or inequality, the solution is going to be everything that is shaded. So it doesn't have to overlap. So we include this in our solution and all of this in our solution. And the neat thing with this is that the green shading for x is less than 9 includes x is less than -2. Okay? So this blue that I highlighted is your solution on a number line. Now let's write that in interval notation. So we always start from the left, so the very left is -infinity. So we're going to say parentheses, -infinity, comma, all the way to 9, and we are not including 9 because it's not equal to, so we're going to use parentheses. So this is your solution in interval notation. Okay? Just so we know the difference, let's say this was the exact same problem, but or said and. It would be an and inequality. If it were and, then you would want where they overlap, and it would only be the part where they overlap over here to the left. But since it's or, we want to include everything, so that's why we have this as our answer here. It doesn't have to overlap. Okay, number 5. Write the equation of the line shown. Be sure to use the correct variable. So this is a coordinate plane. So remember, this is your x-axis, and this is your y-axis. Okay? So the red line is what we're writing our equation for. So the red line is crossing the x-axis. So that means it's going to be x equals. And at what value is it crossing the x-axis? At 2. So the equation is x equals 2. And that's it. So keep in mind that vertical lines are x equals a number, and horizontal lines are y equals some number. Whoopsie. Okay. So that's pretty much the important thing you want to remember here. And you can remember that because it's crossing through those axes. So the red line is crossing through. Any vertical line is crossing up and down. It's crossing through the x-axis. So it's going to be an x equals equation. Okay. Number 6. Now we're going to graph this equation. So y equals 1. So if it's y equals 1, that means it's crossing through the y-axis. So this is your x-axis. This is your y-axis. So it's going to be crossing through the y-axis at 1. So it's going to be a horizontal line going through y equals 1. And that is going to be the equation of that. That is going to be the graph of that equation. Okay? Number 7, find the x and y intercepts of the line represented by the equation y equals -10x minus 2. So let's start with the x-intercept. So to get the x-intercept, you want to set y equal to 0 and solve for x. So if we have y equals -10x minus 2, we're going to set y equal to 0, so it's going to be 0 equals -10x minus 2. And then we're going to solve for x. So we're going to add 2 to get the x term by itself. So 0 plus 2 is 0. 2 equals, bring down that -10x, and then -2 plus 2 canceled out. And so we're solving for x, so we're going to divide by -10. So now we have 2 over -10 equals x. Okay? And then we can always, let me check and see how they wanted your answer. Yeah, we can keep that in fraction form but simplify. So we can reduce 2 and 10 by dividing both by 2. 2 goes into 2 one time. 2 goes into 10 5 times. So -1/5 is going to be your x-intercept. As a point, that would be -1/5, comma 0. Now let's do the y-intercept. So to find the y-intercept, we're going to set x equal to 0 and solve for y. Okay? So if we're going to set x equal to 0, we'll have y equals -10 times 0 minus 2. So -10 times 0 is 0. So we have y equals 0 minus 2. So y equals -2. So as a point, that would be 0, comma, -2. So those are your x and y intercepts. The x-intercept is -1/5, and the y-intercept is -2. Okay, number 8. Give the slope and the y-intercept of the line represented by the equation. So it is helpful here to solve this equation into slope-intercept form. So let's remember what slope-intercept form is. Okay. So that is y equals mx plus b. So m is your slope of the line, and then b is your y-intercept. Okay? So if we can take this equation here, put it into slope-intercept form, then we can easily identify the slope and the y-intercept. So we want to set it equal to y. So to start the process, I want to get the 5y by itself. So let's subtract x and subtract 1 on both sides. That's going to cancel out the x. I'm going to bring down that 5y. I'm going to cancel out 1 minus 1 equals 0 minus x minus 1. And so now we're going to solve for y, because slope-intercept form is y equals mx plus b. So let's divide by 5. So now I have y equals negative x over 5. That's going to be -1 over 5x minus 1 over 5. So now you can very easily identify the slope and the y-intercept. So the coefficient in front of the x is your slope, and then the constant at the end is your y-intercept. Okay? And that is your answer. Okay, number 9. Given below are descriptions of 2 lines. Okay. Okay, so line 1 goes through -9, 66, and -13, 94. These are just points on a coordinate plane. Line number 2 goes through -10, -98, and then -6, -58. So we want to determine first the slopes of each line. So there is a formula to find the slope of a line given 2 points on the line. Keep in mind that on this test you cannot use a formula sheet. So you want to remember these formulas. So the formula is m equals y2 minus y1 divided by x2 minus x1. So what you basically need to do is subtract the y values divided by subtracting the x values. So it can help to maybe label the points. This is point number 1 and point number 2. So for line 1, let's take the y value in point 2. So that'll be 94 minus the y value in point 1, 66, divided by the x value in point 2, negative 13, minus the x value in point 1, negative 9. Be very careful with these negatives. Okay? So now 94 minus 66 equals 28. And then negative 13 minus negative 9 is going to be negative 4. And then 28 divided by negative 4 is negative 7. So the slope of line 1 is negative 7. Okay, let's do line 2. Now keep in mind, it doesn't matter what order you subtract the numbers as long as you're consistent. So for line 2, I could say subtract my y value, so I could say negative 98 minus negative 58 over, subtract my x values, negative 10 minus negative 6. You just have to be consistent. So negative 98 minus negative 58 is going to be negative 40 divided by negative 10 minus negative 6 is negative 4. So negative 40 divided by negative 4 is positive 10. So the slope for line 2 is 10. So you have negative 7 and 10 as your two slopes. You're trying to decide if the lines are parallel, perpendicular, or neither. So if the slopes were equal, they would be parallel lines, which clearly the slopes are not equal. So it's not parallel. If the slopes were negative reciprocals, which would mean they'd be opposite signs, which they are here, but then they would be reciprocals. So the reciprocal of 7 would be 1 over 7. And the reciprocal of 10 would be 1 over 10. So we do not have negative reciprocals here, so it's not perpendicular. So any other option means that it would have to be neither parallel or perpendicular. So the answer is they're neither parallel or perpendicular. Okay? All right, number 10. Find the equation of the line having a slope of 1 and a point 6,5. Write the answer in slope-intercept form. Okay, so there is a form that's helpful to use when you have a point and a slope. So that form is called point slope form. Cool name. So the formula or the form is y minus y1 equals m times x minus x1. So what's happening here is that the m is your slope, and then the x1 and y1 comes from your point. And then x and y stays x and y, and then you just simplify it and get it to the point of slope-intercept form if that's what you're trying to do. So let's plug in the values. So we're going to have y minus 5 equals, the slope is 1 times x minus 6. So we have our slope is 1 and the point was 6, 5. Okay, so y minus 5 equals 1 times x is x, 1 times negative 6 is negative 6. And if I want it in slope-intercept form, remember that's y equals mx plus b. That means we need to get y by itself, so we're going to add this 5. So I'm going to have y equals, bring down that x, the negative 6 plus 5 is negative 1. And this will be your final answer in slope-intercept form. Okay, let's look at number 11. Find the equation of the line passing through the points -2, 0, and 4, -5, and write the answer in slope-intercept form. So again, we can use point-slope form. So I will just write it again up here. Why is this not working? Oh, okay, it's freezing. Where'd it go? Where did it go? Wow, I didn't save on my work. That's whack. Okay. Alright, so where were we? We were on number 11. Okay, gotta love technology. Alright, so again, we're going to start by rewriting. Okay, let's rewrite point-slope form. Which is y minus y1 equals m times x minus x1. So for point-slope form, we need a point and a slope. So we have 2 points, but we don't have a slope. So we need to first find the slope, which is m. And to do that, we're going to use our slope formula. Subtract your y values divided by subtracting your x values. So we've got, let's subtract the y values. 0 minus -5 divided by -2 minus 4. So 0 minus -5 minus a negative becomes positive. 0 plus 5 is 5 over -2 minus 4, same sign, so you add and keep the sign, -6. All right? So the slope of the line that we need for our equation is 5 over -6, or -5/6. And we already have a point. We have 2 points, so we can pick whatever point we want. I'm going to pick this point, just because. So I have y minus, my y value is going to be 0 equals m, which I found to be -5/6, times x minus the x coordinate of the point, -2. Just to make sure you know where everything's coming from, this came from the point, and this is your slope. Okay, so y minus 0 is just y equals, we have -5/6 times x plus 2. And now we want it in slope-intercept form, so we're going to have to distribute this -5/6. So we have -5/6x, and then we have -5 times 2, which is -10/6. And then we want to simplify and reduce our answer, so we can simplify and reduce this fraction here. So 10 and 6 can be divided by 2. So 2 goes into 10 5 times, and 2 goes into 6 3 times. So your final answer will be y equals -5/6x minus 5/3. You can also simplify fractions in a graphing calculator. That is always an option. I can post some videos of how to, simplify fractions in the calculator just to kind of make sure you don't miss points for doing things like that. Okay. Number 12, find an equation of the line. Okay. So, I got a question. Let's see. 1 second. Okay. All right. Okay, let's keep going. Okay, find an equation of the line containing the point 1, 1 and parallel to y equals 4x plus 3. Okay, so if you have parallel lines, that means that the lines have the same slope. The slopes are equal. So the slope of the line that we need would need to also be 4. And then we are given the point 1, 1. So we're going to use point slope form, which is y minus y1 equals m times x minus x1. Okay, 1 second. Okay. Oh, wow, I did say 12. Wow. Oh, I had it on my calendar for 11. I'm so sorry, guys. You are correct. I got called into meetings all day yesterday, so I had to reschedule it. And I made it 12. Wow. I'm so sorry. I was still thinking 11. I had it for 11 on my calendar. But I sent you guys something saying 12. Which doesn't make sense because I have a 1 o'clock meeting. I apologize for that. Okay. So I will, again, I will post the session. I was always going to post the session, but I do have to do it at continue because I have a meeting at 1. So that's why I don't know why I typed 12. Wow. Okay. That's my fault, guys. Okay. So we're going to keep going. I will be here until, I'll probably stay till about 12:30, 12:40. Yeah, good. Yes, good thing. Someone said good thing they came early. See, someone was here at 11, and I was thinking, yeah, let's get the party started. But my apologies, guys. Canvas actually has something that we could use, but I have 2 online classes, and it's much easier for me to use this and not use Canvas because I can't merge classes together. Anyway, I'm rambling. Let's keep going. The slope is 4. And then the point we're going to use is 1, 1. So let's plug in our values. So we're going to have y minus 1 equals 4 times x minus 1. And so now we're going to distribute this 4. So we have 4x minus 4. So on the left I have y minus 1 equals 4x minus 4. And then I'm trying to put it in slope-intercept form. So I'm going to add the 1 to set it equal to y. So I'm going to have y equals 4x. Negative 4 plus 1 is negative 3. And this will be your final answer here. Okay?
Okay.
All right. Let me see. Okay. So now find an equation of the line passing through the point 10, negative 6, and perpendicular to negative 15x plus 3y equals negative 9. So in order to figure out a perpendicular line slope, we need to find the slope of the given equation first. So let's put this in slope-intercept form, identify that slope, and then we're going to take the negative reciprocal of that slope, and that will be the slope that we use in the line that we are going to write. So we're going to take this equation here and put it in slope-intercept form. So to do that, I'm going to add the 15x on both sides. So I have 3y equals positive 15x minus 9. I'm going to move that to the other side. And now I'm going to divide by 3. So I have y equals 15 over 3, x minus 9 over 3, which will reduce to just y equals 5x minus 3. So now, this is the slope. So 5 is the slope of the given equation. But the slope that we need needs to be perpendicular. So we're going to take, so the given slope is 5. But we need the perpendicular slope. So we're going to do the opposite sign. So since the given slope is 5, our slope needs to be negative, and we're going to take 5 and flip it. So it's going to be 1 over 5. So this is going to be our slope, negative 1 over 5. That's what we're going to use. So now we need a point, which we were given a point. So we have a point, and now we have a slope. So point slope form is y minus y1 equals m times x minus x1. So the point will go here for x1 and y1, and the slope will go here for m. So we have y minus negative 6 equals our slope, our perpendicular slope, negative 1 over 5 times x minus 10. Because remember, these values came from the point. This value came from the perpendicular slope. So now we're going to distribute this negative 1/5. So negative 1/5 times x is negative 1/5 x. Negative 1/5 times negative 10 is positive 10 divided by 5, which is 2. So y minus negative 6 changes to y plus 6. And then finally, we're going to subtract 6 on both sides to end up with y equals negative 1/5 x. And then 2 minus 6 is negative 4. And this is going to be your final answer. So we had to use the equation that was given to us to find out that equation's slope. And since it's perpendicular, we need to take the negative reciprocal, which 5 gave us negative 1 over 5. We use the point they gave us, and then we use point slope form to get the equation of the line. Okay? 14. Find the equation of the line passing through the point 9, 0 and perpendicular to y equals negative 3x minus 5. So for this one, we don't have to do any major work to get the slope because it's already in slope-intercept form. So we can just take the slope that's given to us. This is negative 3. That's the given slope, which is negative 3. We want the perpendicular slope. So the perpendicular slope, we're going to flip 3 into 1 over 3, and we have to do the opposite sign. So it's going to be positive 1 over 3. So we're going to use that 1 over 3 for our slope, and then we're going to use this point, and then we're going to use point slope form. Y minus y1 equals m times x minus x1. My throat just got super dry. Okay. Excuse me. Okay, so now we're going to take our point is going to plug in for x1 and y1, and the slope is going to be the m. So we have y minus 0 equals m, which is 1/3, times x minus 9. Just so we know what we're doing, these values came from the point. This is your slope. So now, y minus 0 is just y equals, now we're going to distribute this 1/3. So 1/3 times x is 1/3 x. Then 1/3 times negative 9 is negative 9 over 3, which will reduce to y equals 1/3 x minus 3. And that is your final answer. Okay. All right, 15. Find the domain and range of the relation. So the domain is all of your x values, and the range is all of your y values. So we've got all of your x values will fall in your domain. All of your y values would fall in your range. So the domain would just be 5, 8. We don't have to list 5 again. 18 and 21. And the range would be 2, 9, 15, 19, and 25. In MAT1033C, they want you to not put spaces, so just be sure and read the directions when you answer the questions. Yeah. Okay, and that's it. Number 16, find the domain and range of this relation and write it in interval notation. Okay. Oh, that went too high up. There we go. All right, so the domain is all of your possible x values. So let's look at the x values, go left to right. Okay? So if I take a look at my x values of this graph, is this blue part. It starts right here at -1. It starts here, and it goes all the way to 3. Those are where all of your x values lie. So here at -1, it's a closed circle. So if we're going to write it in interval notation, we're going to use a bracket to say that we're starting at -1, and we do include -1 because it's a closed circle. And then all the x values continue all the way to +3. Now, notice it's an open circle. So that means that we are not going to include, write that better. That's an open circle. So we are not including 3. We're going to use parentheses. Okay? That's the domain. Let's look at range. Range is your y value. So we are going from the bottom to the top. So your y values start at 5. They start at 5 and they go up all the way to 4. So we're going to start at -5. It's an open circle. So we are not going to include 5. We're going to use parentheses. And we're going to go all the way up to 4 on the y value. And this line does touch 4, so we're going to use a bracket. Okay? Yes, good. So I have a question that says, we always check the y value starting from the bottom. Yes. So we always, and she may not can hear me, so let me type it real fast. Can you hear me? Just curious. So you're going to always start. Oh, what happened? Okay, great. Okay. So you always start from the smallest to largest. I'm trying to talk and type at the same time. Okay, so you always start from the smallest to the largest. So for the domain, which is the x, that's left to right. Range, which is your y, is bottom to top. Okay? Okay, hopefully that made sense. That's a very good question. Excuse me. Okay, awesome. Okay, very good question. All right, so that's your answer. That is your answer. Now let me tell you, just so you know, your test review, you can do unlimited attempts, and you can do a question over and over and over again. And I'll probably pull up the review. You guys can look at it with me so I can make sure you know how to use it. Okay, another one. Find the domain and range of this relation. So we can practice this again. So domain. Now the graphs are kind of weird. Assume there's an arrow if the relation exits the graph. So what that means is that right here, assume it's continuing on. Okay? Also assume that the end point is an integer. What that means is assume that this is ending right here. Okay? It's hard for the computer program to graph it super accurately, but that's what this in parentheses means. Okay, so the domain. So we're talking about our x value, so we always go left to right. So we're going to start, the very left of this graph is at 2, and it's going on, and it's an arrow, so it's going on and on to infinity. So the domain is going to be Why can't you guys hear? I don't know what's going on. You'll be able to hear the video, but I don't know what's going on. Okay, the domain is starting at 2. This is the x values. So we're going to use a bracket because it does start actually at 2. And then we're going to go all the way to the right to infinity. And you always use parentheses for infinity. Let's see. So start from the bottom. It starts at -4. And we're going to use a bracket because it does, you know, it is a point on -4. And then it keeps going on and on, up and up. And technically what's happening is going to go up and 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 up, on and on into outer space. So not only is the domain going on and on and on, the range is going on and on and on as well. So that will also go to infinity. Okay? Yeah. Okay. So I think someone joined by phone, which is good. I don't know why it's making you do both, but that may be what has to happen. Okay. I'm going to mute whoever just joined by phone, just so I don't get feed. Oh, they left. Got a question. I always use the bracket when I have a closed dot. Yes. So the bracket represents that we are including that value. So the closed dot means that we are including that value as well. An open dot or circle represents that we are starting at that value, but we don't include that actual value. I'm typing people. I know, I'm typing because a lot of times you guys have questions and they're good for everyone. I don't know who is still just watching me and can't hear me, so that's why I'm saying the question and also typing it. I know I'm a mess today, clearly, but thank you for putting up with me today. All right. Yeah, so it's similar to when we have like less than or equal to. So like, you know, x is less than 2 means that we're talking about all the values less than 2, but not including 2. X is less than or equal to 2 would mean we're talking about all the values less than 2, and we're including 2. So that or equal to is just like if we used a closed dot, just like if we used a bracket. So I hope that made sense. Okay, so let's keep the party started going. Okay, so now another domain and range. So and you're not going to have as many of these on the test. You're going to have like, I think the test is just 20 questions and the review is 26. So sometimes you have multiple types of questions on the review because I wanted to make sure you see some questions. I wanted you to see all the different types, but you probably only have one find the domain and range of a graph on the actual test. So just kind of keep that in mind. But it's always good for your review to be longer than the actual test, just FYI. Anyway, okay. Excuse me. All right, let's do another domain. So the domain, all of your x values, so we're thinking left to right. So remember, if the graph cuts off at the cuts off the screen Think of it as having arrows. Okay? So what's happening is that this domain, it actually doesn't start at -5. It's starting at way over here. It's starting at -infinity. So the domain starts at -infinity, and it goes on to +infinity. So the domain is actually all real numbers for this. Okay? Now, your range, which is your y values, start from the bottom. So at the bottom, we have an arrow telling us that we are starting from, you know, it's not stopping. So there's no actual starting point. So for the range, it's actually starting at -infinity. And it's going all the way up to y equals 1. It stops at 1. So we're going to say 1, but there is a point on y equals 1, so we're going to use a bracket. Okay? So remember, domain, you think left to right, all of your possible x values. Your range, you think bottom to top, all of your possible y values. So I got a question, what about the points that the line touches at the x value? So are you referring to like -4 and -2? Okay, good question. So this is asking you for, so think about domain and range as like you're describing the range that your graph covers, right? So your domain is all of your possible x values on the entire graph, not just where it crosses the x-axis. Which you just mentioned, those are x-intercepts, but they're asking you for the domain. So all the possible x values. So -4 and -2 are a part of your domain, but that's just those 2 points. So the domain, and if you just kind of think, if you look at a graph and start from the left side of your graph and take your eyes and move it to the right and see if you have, you want to make sure your domain represents all the possible places where your graph is. So if you are starting at the left of that graph, the very left, like there is a, your graph is beyond -4, and your graph, if we move to the right, it moves beyond -2. Does that make sense? This is a kind of difficult concept, so when I ask you does it make sense, I'm not, being weird. I want to make sure I'm making sense. So it's kind of an abstract idea. Okay, good. And sometimes even you can take your hand, I know I can't really show you, but if you take your hand and literally like move it left to right, it almost helps you kind of see all of your possible x values. And then for range, go all the way to the bottom and just move your hand up and see if your hand is touching graph. And once your hand stops touching graph, then your range or your domain would stop at that point. You'd want to have like some kind of distinction of where it stops. Okie doke. So 19. Find the domain and range of the relation. Write an interval notation. So again, you're not going to have 4 of these on your test, but I wanted to make sure you see, because like I said, these are the more difficult ones, so I just wanted to make sure you get a few of them when you do your review. All right, so domain. We are starting from the very left, and remember for these, assume these are arrows. So your domain is left to right. So your domain, what do you guys think it would be? You can type it. What do you guys think for your domain? I already gave you one hint because I was about to write it. Yes, it starts at -infinity. Very good. And it's going to go all the way to, hey, I like it, +infinity. Very good. Very good. Excellent. I'm silly, y'all. If y'all see me face to face, I'm silly. Okay, so I'm in here by myself laughing. All right, so yeah, very good. It's negative to positive infinity. It starts all the way, because technically this is going on and on and on and on and on. This is going on and on and on and on, but we just can't see that. So your domain is all real numbers. It does not stop. It just keeps going. Let's look at range now. Let me erase these weird lines. Okay, so now the range, think bottom to top. So the range is going to start with what?
1.
Bottom to top.
Oh no.
You did top to bottom. Always think bottom to top. So if it's starting at the bottom and you've got arrows representing that it's actually continuing, where would we start for the range? Good. Negative infinity. Very good. And then it's going to go all the way to, does it go on to positive infinity, or does it actually stop at a certain point on your y values? Remember, range is your y. It's going to stop at, somebody said it too early, it's going to stop at 1. Very good. So it goes all the way. See, I drew my arrow too far. It doesn't go this far up. It goes all the way and it stops right there because your graph stops there. So it's going to go all the way to 1, but there is a point on the graph at 1, so we're going to use a bracket. So I got a question. If the graph is located on the right side, the infinity is positive then. No, are you saying, so I'm just going to draw one. Like if it looked like this, for example? No, it would still be negative infinity because what it's doing, it's basically, this is like you can't, it's almost like if this is slowly getting bigger and bigger, even though it looks like it's not, it'll eventually end up way over here. So this is just saying that this arrow means it's continue. As you move to the left, it's continuing on. It's not stopping. No matter how far to the left I go, it's still negative infinity. So it's not because we're on the left side of the graph, it's because the arrow is going to the left side of the graph. Does that make sense? Okay, cool. Yeah, good question though, because I can see why you would think that. Okay. Number 20, determine if the relation is a function. Whoa. Whoa, whoa, whoa. So there's a, oh my goodness, there's a simple way to answer this question. You don't want any of your x values to repeat. So every x value should only produce one y value. So if an x value can get you 2 different y values, then it's not a function. So if you look here, right here, we've got 11 going to 3 and 11 going to -4. Let me also make what's called a mapping, just to show you what I mean visually. So I'm going to list my domain and my range. So for my domain, I've got, let's see, and I'll try to put in order. 11, well, it's not going to be in order, but it doesn't matter. 11, 12, -16, -15. Then the range will be 5, -12, 3, 6, and -4. So I'm going to connect them based on the points. So 12 connects to 5. -16 connects to -12. Let me not use arrows. I'll just connect it. 12 goes to 5. -16 goes to -11. 11 goes to 3. -15 goes to 6. And 11 goes to -4. Okay, so this relation, because of this right here, the answer is no. It is not a function. Okay? because you never want to have an x value, an input of an x value, give you two different outputs. Now, you can have, you know, like different inputs could give you the same output. That's okay. Like, let's say I had another number and it also connected to 6. That would be okay. You just never want an x value to repeat and be connected to a different y value. Okay? So the answer here is not a function. That's how you can tell based on like a set of numbers. Now you can also tell if a graph or a relation is a function by looking at a graph. And by finding that out, you're going to use what's called a vertical line test. Okay. All right. So what that means is that I'm going to use a red line. If there's ever any, if you take a vertical line, and if you can cross that graph more than once using that one vertical line, that means your graph is not a function. So for example here, no matter where I draw my vertical line, I never cross that blue graph more than one time. So this would be a yes. This one down here, if I draw a vertical line, it fails the vertical line test because it crosses the graph here, here, and here. So this would be a no. This would be a yes. It passes the vertical line test. This would be a yes. This one would be yes. This one would be no, because if I take a vertical line, it crosses the graph more than once on that one vertical line. So for this problem, you would select, it would be like a multiple select question. So you would select all of the graphs that are functions. So the only ones that are not functions would be this one here and this one here. And that's called the vertical line test. And just to compare it to what I just mentioned before, so what's happening, like say here, let's say my circle. If we look at when x is -1, it gives you two different y values. It gives you when x is -1, you know, y looks like it's 0 and it's 2. So that's like what we just did on number 20. So the x of -1 gives you two different y values. That's why it's no. You're just looking at it visually on a graph using a vertical line. That vertical line represents your x values. Okay, number 22. Okay, the function f of x equals x squared minus 6x plus 3 is given. Find f of -2. So this is function notation. And what this is saying is that everywhere you have an x, you're going to plug in -2. So it's going to be -2 squared minus 6 times -2 plus 3. So -2 squared is -2 times -2, which is positive 4. -6 times -2 is positive 12. And then we're going to bring down that plus 3. So now 4 plus 12 is 16 plus 3 equals 19. So f of -2 equals 19. So now instead of saying, you know, evaluate the, you know, expression when x equals -2, we can just say find f of -2. That's function notation. Just a way of saying something in a much shorter, more concise way. So that's your answer there. Oh, jeez. Okay. 23. Use the graph of the function f of x to find f of 1. Okay. So, something else to keep in mind, f of x is the same thing as y. So we often say y equals, and we have our equation. Well, f of x is the same thing as y. So if you see f of x, you can even substitute that for y, so it makes more sense to you in terms of an x and y coordinate plane. So it's saying to find f of 1. What this is saying is that when x equals 1, find y. That's what that is saying to you, but in function notation. So if we want to know on the graph, when x equals 1, find the y value, let's look at when x equals 1. So that's an equation, right? So let's go to the x-axis, go to 1. I'm just going to draw x equals 1. That's supposed to be a straight line. Okay, and I'm drawing the line because I want to make sure I don't miss anything. Sometimes your graph, you may end up getting more than one value. So when x equals 1, my graph crosses it right here. So when x is 1, what is my y value? At this point, when x is 1, the y value is 3. So the answer is 3. So f of 1 equals 3. That is your answer, 3. So it's knowing what function notation means, so that little simple little expression, f of 1, actually is asking you a more kind of elaborate question. Okay? So when x equals 1, find y, because f of x equals y. So they're saying when f of 1 equals what? So if the x is 1, what would be the y? And so in this case, when x is 1, the y value is 3 for this graph. All right. Just to practice another one, I'll do find f of 2. So that is asking us, when x equals 2, what does y equal? So if I go to the x-axis, here's 2. If I were to look at what's happening on my graph, it's crossing it here at y equals 1. So the answer here would be 1. Very good. Good job. Good job. Saw somebody got the answer. I was taking too long. Good. So like I said, it's kind of weird at first, but just remember what this function notation actually means. And it helps to kind of draw. So now here's the kind of the annoying thing. I know this is an online class, so you really can't draw, right, on the computer. But if it helps you to kind of sketch these graphs on your scratch paper, please do that. Or you can take your finger and kind of like draw your lines with your finger. But just don't be afraid to use paper when you're doing these problems, because I know they're all on the computer. But don't, not write things down. You can kind of get used to not writing things down because you don't have to. Okay. Oh, somebody figured out how to work it through their computer. I think it's Jessica. Jessica, do you mind sharing how you got your sound to work? because I can actually hear you. You can just talk if you want.
Oh, can you hear me?
I can.
Oh, cool.
Yeah.
On the top of the layout where you're actually writing on, there's a dial-in phone number with an American flag and an access code. And so right underneath that is a little camera and a little telephone. I just clicked on the telephone.
Ah, okay. Okay. So I need, thank you for telling me that so I can know what to tell people.
Yep.
And that's
and
what I had to do to talk. Oh, okay. Go ahead.
I think there's a little microphone. I put myself on mute. I'm going to go ahead and mute myself because I'm actually at work and I didn't want you hearing my background noise.
No, you're fine, but thank you for sharing that with me so I can, in the future, can let people know to do that because people weren't hearing me and that defeats the purpose. Thank you so much.
Okay.
All right.
Thank you.
All right. So, awesome. So next time we will be good to go. Okay, so find the domain of the function. F of x equals negative 6x squared plus 2x plus 8. So now we're finding the domain of a function algebraically. So there are kind of two red flags you want to look for. You want to check for variables in the denominator or square roots. So we want to look for denominators and then square roots. Here we don't have either one of those. There's no denominator and there's no square root. So if you don't have one of these red flags, then the domain is all real numbers. What that means is that there are no x values in the real number system that will make your function be undefined. And then in your MAT1033C, they want the answer in interval notation. So that would be negative infinity to positive infinity. Okay? So no denominator, no square root. That means the domain is all real numbers. Now, of course, we're going to look at some when you do have those situations. And then what would we do? Okay, so now we do have a denominator here. So what do we do? So if you have a denominator, a function is undefined when you have 0 in the denominator. You can't divide by 0, that's undefined. You can ask Siri and she'll tell you no too. So what we want to do, we want to take the denominator. Yes, when we don't have one of those two red flags, it is always all real numbers, negative to positive infinity. Very good. Okay, so when we do have a denominator, we want to take the denominator. Let's set it equal to 0. And then we want to solve. Let me do steps. We're going to set the bottom equal to 0. Solve. And then we're going to exclude those values or value from the domain. I can't spell today. Okay. So if you have a denominator, you're not going to have all real numbers because that means that something, if you have a variable in the denominator, there could possibly be a way that you can end up with a 0 in the bottom, and that you don't want that to happen. So anytime your x could give you a 0, you want to exclude that from your domain. So let's figure out when the bottom would be 0, solve it, and exclude that from the domain. So I'm taking the denominator and I set it equal to 0. This looks so messy. Make that neater. So negative 6x minus 12 equals 0. Now we're going to solve it. So I'm going to add 12. Negative 6x equals 12. Divide by negative 6. So x equals negative 2. That is not my domain. That is the value that we don't want in the domain. Because if x equals 2, negative 2, that means what I've just boxed in, the denominator, would end up equaling 0. So if you think about it, if I think about it on a number line, if it's all real numbers, except, okay, that didn't work. So if it's all real numbers, except at negative 2, then that is my domain. So it's like if I had an open circle at negative 2, but everything else is okay. This is how it will look on the number line. So why am I excluding negative 2 again? Because negative 2 would make the bottom be a 0. And anything divided by 0 is undefined. So the domain would be what I just grabbed here. So let's write that in interval notation. So we would start from the left, because domain, all of your x values. So we start from the left, and that would be negative infinity all the way to negative 2. But are we including negative 2? No, we are not. So we're going to use parentheses, and then we have another interval, so we're going to type U, which means the union. We're including them both. And then this next interval starts at negative 2, but we're not including it. And it's going all the way to infinity. So that is your answer for the domain for this function. Okay, I think I have a question. When we don't have those, oh yeah. Yeah, I'll explain another one. Sure, I'll make up another one. Just 1 second. Okay. All right, so let me make up another one. Let's see. Where'd that blank page go? Up there? Okay. That's random. Okay, so I'm going to make up one. Find the domain. And we'll say f of x equals 3 over 2x plus 1. Okay, so we want to find the domain of this function. So we have a denominator. That's a red flag. So when you have a denominator, you want to set the bottom equal to 0. And it's going to be all real numbers except for whatever you get here. So if I solve for x, 2x equals negative 1, divide by 2, x equals negative 1/2. So the domain is going to be everything except x equals negative 1/2. So what would that look like on a number line? And I like going from number line to interval notation. It just makes more sense in my head. So if I've got negative 1/2 here, I'm not including it because that would make the bottom 0. But it's everything except that. Okay? So if I write it as an interval notation, I would start at negative infinity. So this first interval here is negative infinity all the way to negative 1/2 with parentheses. because we're not including negative 1/2. And then the union of this interval. So we're starting at negative 1/2 with parentheses because we're not including it all the way to infinity. So that would be your domain. All right. Okay, so now we're going to do one with a square root. There we go. Okay, so now find the domain of the function f of x equals the square root of negative 8 minus 2x. Okay, so if you have a square root, what do? So you're going to take the radicand, set it greater than or equal to 0, and then you're going to solve it, and the answer is the domain. Now, radicand, what is she talking about? So the radicand is just what's underneath the square root. Okay? So, for a square root, what makes a square root undefined? We don't want the square root of a negative number. The square root of a negative number takes you outside of the real number system. We are going to learn what you do get, but that's not until early November maybe. So right now, since we're only talking about real numbers, if you have a square root of a negative number, you could put it in your calculator. It'll tell you error, or something undefined. So to figure out what your domain would be, you can just take what's under the square root and set it greater than or equal to 0, because that would be okay. And then whatever you get, that is actually your domain. So for this problem, I'm going to take negative 8 minus 2x and set it greater than or equal to 0, because that is what I do want to happen. Okay? Whatever's under the square root, it can be 0 and it can be greater than 0 because it'll be positive. So let's solve this and see what we get. So if we add 8, because we're trying to get that x by itself, I bring down that negative 2x is greater than or equal to positive 8. And then I'm going to divide by negative 2 on both sides. Remember, when you divide or multiply by a negative across an inequality, you have to flip that inequality sign. So now I'm going to have x is less than or equal to 8 divided by negative 2, which is negative 4. So that's your domain in like inequality form. But to write this in interval notation, let's graph it so we can just kind of get an idea of what it would look like. So if I have negative 4, x is less than, so all the values less than negative 4, and then less than or equal to. So we are going to include negative 4 with a closed circle or a bracket. And so the interval will look like this. It would start at negative infinity, and it would go all the way to negative 4 with a bracket. Okay? And that would be the domain for this function, which was f of x equals the square root of negative 8 minus 2x. Okay? Now, before we go, let me pull up a test review just so I can make sure you guys know what it looks like. There's no questions. Okay. Okay. Okay, so this is what a test review looks like. So you have unlimited attempts on here. Keep in mind your grade, your grade on this review is a lab grade. So you want to give yourself ample opportunity to do the best that you can on this assignment. And I'm actually going to have this assignment available for you to work on throughout the semester. But you have unlimited attempts. So remember, when you do any problem in iMath.AS, this is going to be your homework, test reviews, quizzes. Remember, this little yellow button, this little yellow thing here is very helpful because it helps you input your answers. Or even if you have something like this and you need to type something, if you want to type exponents, square roots, infinity, we're not really using these yet. The next section you'll use these more. Just utilize that, okay? Now you have unlimited attempts. Let's say I put the wrong answer here and say submit. I can reattempt the question. I can reattempt it. It'll give me another version. Let's see. This is what x equals -4. And you can still do it again if you want, but it's going to remember that you got that answer right. Okay? But you can skip around and do, you know, take your time with it. It's recording your answers. You could print if you wanted to, but I don't know. I think if you print it and you leave and come back, yeah, it'll probably be the same. I'm not 100% sure of that. This is how your review looks. If you click here, it'll give you kind of your instructions. Enter your interval using interval notation. You can click here. It'll tell you how they want the answer entered. That's the same for your homework as well. So this is what your review looks like. You can always use the preview button to make sure you typed what you thought you wanted to type. Remember, this math editor is here to help you as well. So yeah, I just kind of wanted to look at the review with you guys. If I have any questions on the first ones that I could not see, can I ask you? Yes, so I'm going to post the review of the video of this session. What if you have the first one right, but you still want to keep practicing? Can I do that and keep the high score? You know what? Let's test it out. So I got that one right. Let me get this wrong. Okay, yeah. You see how it has score in gradebook? It still has that 1/1, and you can still see it here, but it did show you that you got this wrong. So what that means to me is that it's still keeping your grade. Does that make sense? It's still remembering you did get this right. So you're getting that 1 out of 26. So if I get this right now, if you had it right but you want to do a similar, that's what I just did. So reattempt last question. Yeah. So you see how it has, it's still, for question 5, it still says 1 out of 1. I still have a 1 out of 26. That's the one I got right. But I am still reattempting that question. So here I'm going to reattempt this. I'm going to get this wrong on purpose. X equals 0. That's not the right answer. I'm going to submit. You see how it's telling me the score on the last attempt is 0 out of 1. I'm practicing again and again. But remember when I did get it right a few questions ago, it's still remembering that here. So you can keep practicing and you still can maintain your correct answers that you did get in the past. Yeah. You know, reattempt last question. try it again. So this would be x equals 5. Submit. Your grade didn't change. You just know that you got this one right. So that's kind of how your quizzes are set up, but you only have 3 attempts for each question. But yeah, so you've got a full week, and you may not have even gotten to all the material yet. I understand that, but I want to go ahead and do the review ahead of time. So the test is in the testing center now. In any Valencia testing center, you have from now until the 17th, which is next Monday, to take the test in a Valencia testing center. You may use a graphing calculator, but that is it. You may not use notes or a note card. You have 2 hours to complete the test, and you can use scratch paper, blank scratch paper, but you'll need to turn that scratch paper in when you finish the test. You are welcome to come to the depot at any point for any help from our tutors. If I'm available, I'd be happy to help you. And also remember, there is Smart Thinking, which is free online tutoring at 24/7, 7 days a week, 24 hours in a day. You have access to free tutoring online. You can get to that via Atlas. And then I'm going to have this video posted. I also have older videos available in the course that you can watch. But like I said, this test review is going to be a great way for you to review for the test. And keep in mind, all of your Unit 1 work, your homework, your quizzes, the final deadline for all of that is the 17th as well. So I do have due dates weekly in Canvas. That's to help you stay on pace and stay on track. But you can know that you have the entire unit to actually get everything done. So if there's no other questions, and if anybody missed, if they dropped by, I mistakenly, crazily told you guys 12 p.m. for the review session. Put on my calendar 11. I never changed it to 12. So I started at 11. And so I apologize for that confusion. That was completely my miscommunication. But I am going to post the video so that you can see everything from number 1 until 26. So you guys keep it up. Thank you so much for joining this session and asking questions. That's why I do this, so I can have time to help you guys and answer questions. And even if you have questions for me and you want to have an individual session like this, I'd be glad to schedule this with you. I could do 15 to 20-minute sessions with you guys. I would just give you you'd have the access code. You can join in, and we can have a brief session with just myself and you if you can't make it to campus. Just give me a heads up. Send me an email. Send me an email, and we can coordinate a time that will work for both of us, and I can do some about 15 to 20-minute sessions with you. I'd be glad to do that. So thank you. I appreciate you guys saying it was helpful. I'm so glad to hear that. I want to be helpful to you. So just work hard, focus, and I will see you online. So I'll be on the lookout for an announcement with the link to the video, and I'll also post it in the live sessions page that's in the modules. All right, so you guys have a great rest of the day. Talk to you later. Bye-bye.